All right, I think we should probably get started since it looks very cozy in here, and I don't want to keep you any longer than you all have to be because it's the last session of the day, I believe, and you probably all have big plans for tonight, as most of us do. So I guess since some of you weren't in my previous session, I have to introduce myself again. My name is Greg Kazanza. I'm a program manager on the VMM team. Worked on the team for about 3.5 years. My primary area that I work on now is networking across the product. So I've worked closely with the core networking team in Windows Server, a lot of the other teams we have in our India Development Center, and a lot of different partners out there, third-party partners that work with us. I work with them directly, so I see a lot of familiar faces out in the audience as well. So, just a quick recap. For those of you that missed part one, I talked about basically how do you set up your fabric infrastructure. If you're starting from scratch, what are the things you need to take into consideration? How do you design your network? How do you plan your hardware? And then how do you actually deploy it with VMM? I did it from the focus of just using general technology of VLANs, PVLANs, and your basic fabric infrastructure. What I saved for this session is really talking about how you can use software-defined networking in VMM and Windows Server to really expand and build on top of what you just did as far as setting up your basic infrastructure. With software-defined networking, you have a lot of advantages to be able to extend the capabilities even beyond what's in the box and make your environment much more dynamic. Because those of you that were in the first part saw me create, what is a very what I would call it considered a static environment, right? You created VLANs in your logical networks, you expose them as tenant networks, and use them for host functions. But you don't want to be creating those VLANs and updating your switches every time you have a new set of VLANs. You don't want to be moving those VLANs around wherever a tenant needs to go, just because that's a lot of work for you, for your network admin. It's easy to make mistakes. So we'll talk about what are the advantages of why you would use network virtualization as the primary way to create these tenant networks. And a lot of people don't really realize that, if you listen to the keynote yesterday, and if you went to VJ's What's New in SP1 session, Microsoft does have a complete software-defined networking stack, that I'll talk about here as well. So we'll cover that. And if you did miss the first session, the recording is online. I've updated the slides since what was posted on the ComNet or wherever it is you download the slides from. One thing I want to go to, though, before I move off of the first session, go back to my demo environment. One more thing I wanted to show you. I mentioned it, but I didn't actually show it to you. The port profiles for the virtual ports. I just want to show you the settings that are available in those. So if I go back to my fabric and open up one of the port profiles that I actually used in the demo. So let's go to cluster, for example, and open up the properties of that. You can see that a virtual port profile has actually quite some different settings from what you saw in the uplink port profile. This is the cluster one. We worked with the cluster team to build this one. They gave us the settings they recommend. So they told us to enable these offloads. So we will apply these settings automatically. The security settings, they don't generally apply here. And then what bandwidth weight to give, so this minimum bandwidth weight. I believe we put this one higher than the other ones so that the cluster traffic will get a higher priority because you don't want to lose that cluster heartbeat. So I just want to go back and show that because I didn't actually show that to you in the previous session. All right, so yep, if you're here for part two, you're in the right place. Let's move on and talk about software-defined networking. So I started to mention this. The idea with software-defined networking is that you want to take what you have in your physical infrastructure, and you don't want to have to change it every time you have a new tenant, and every time you want to essentially bring some new technology, new software into your environment, new management techniques, things like that. So in 2012, we introduced the concept of logical networking to let you model the physical network. But for software-defined networking, we had to add a lot of concepts to build off of that. Starting with, as I talked about in the first session, the VM network. The VM network, the ones I showed you in part one, were really just pass-throughs. Even the VLAN ones, in a way, are just pass-throughs directly to the VLAN in the underlying fabric. They don't have their own address space. They don't have their own, they don't get realized on their own. They're really just saying, this user can access this VLAN that you've defined on your fabric. But with software-defined network, what you really want to be able to do is let the tenant create their own address space that's completely independent of the fabric. And that's really the purpose of why we created these VM networks. If it was just a matter of exposing VLANs and giving access control, we probably wouldn't have gone to this effort. The VM network really, with network virtualization, gives you a container to put the customer address spaces, a place to put the customer address spaces, so the ones that the customer defines, into a container that they own and they can create on their own. So you can have a subnet for the VMs that's completely independent of what you actually have on your physical fabric. That's really part of our software-defined network strategy. If you look, though, what happens underneath that, or in between the VM and parts of the network virtualization filter, there's a really powerful virtual switch that runs inside the Hyper-V host. This virtual switch is extensible. It's not replaceable. You can't replace the basic functionality of the switch. All the port settings of the switch are still available. But what you can do is add extensions. You can add more than one of certain types. You can only have one extension doing forwarding, or one entity. It's either the Hyper-V switch or the extension doing forwarding. But you can have multiple other types. You can have multiple filtering extensions. So you can use a firewall extension along with your forwarding extension. You can use a capture extension if you have very specific capture requirements that aren't met by a single vendor. So you can plug all these extensions into your switch, and you can do it through software. So you can really build off of what we have in the switch with third parties on top of that. That's really the other part of the capability of the switch for software-defined networking. And then even within the native functionality itself, Hyper-V gives you a great number of settings that you can basically configure on the switch as far as controlling certain types of policies, certain offloads, and that sort of thing. And that's all done essentially through software in the switch as well. In some of these cases, it is assisted by the hardware. So SRIOV, for example, it really does depend on the hardware you have. But it is enabled in the switch and gives you that option to use it. Really, the benefits, obviously you can get things deployed faster, because if you use network virtualization, you don't have to go to your network admin every time you need a new VLAN, or even if you do it yourself, you don't have to go to the switches to enable a VLAN and make sure it does all the necessary routing. These VM networks can be created on the fly. We can update the router for network virtualization, so the routes will go through the gateway from VMM. There's less management overhead. If you use VLANs, you have to make sure you don't waste them, right? You don't want to, when a tenant's done with a VLAN, you have to put it back in the pool so it can get reused again. With network virtualization, with the millions of virtual subnets you can have, you create a tenant and then you delete them, and we'll eventually recycle that virtual subnet, but I actually don't know if we ever will, to be honest. It's not needed because there are just so many of them. So we can spin those up and delete them on the fly. You're able to migrate now without being tied to what your physical infrastructure does. So we talk a lot about two different scenarios. We talk about hybrid cloud or hybrid networking when we talk about network virtualization that lets a customer of a hoster extend their on-premise address space. And in this case, when you have multiple customers, they can each have overlapping address space. You lose some of that when you have just a private cloud and you're routing directly onto a local network, because there the address space can't overlap as much. But because you can still migrate independently of the physical infrastructure, you still have freedom to move, and that's one of the great advantages, even if you are using a private cloud. I'll talk more about this in a little bit. Better utilization of the capacity, that really comes from your ability to migrate, so you're not as tied to these broadcast domains or your VLANs that you were initially deployed on, because your address space isn't tied to that. And I wasn't just lazy by putting and more. I mean, and when I say and more, I really mean it's extensible, right? You have the extensible switch where third parties can come in and they can basically add things that Microsoft didn't think of and build on it. And that's really where the partner ecosystem comes in that I showed in the previous slide. So in this session, I'm going to talk primarily about virtual switch extensibility in the first half, and then I'll move on to talk about the network virtualization, how you enable that, and in both these cases, I'll be building off what I did in the first session. So if we go back to the diagram we started with in the other session, when we look at virtual switch extensibility, we see these switches appear on the Hyper-V host, right? That's where they live. That's where the extensions get installed. And here you see there are 3 different extensions. Well, you basically have an extension running, in every host that in your environment. So It's easy to manage if you only have a handful. If you only have 3 hosts, you can manually deploy those switches or those extensions. But when you get up to hundreds, or you get up to our maximum scale of 1,000 hosts, you don't want to go out and deploy those switches, every time manually and update them manually. You don't want to apply the settings to each host independently, and that's really where the power of the logical switch comes in, right? I showed you how you can make your environment consistent, for just the native settings of the switch, but really the logical switch is the only way to actually deploy from VMM an extension and configure the extension through VMM. So that's one of the key reasons why we built the logical switch, was so we can do that deployment and maintain that consistency. With a standard switch in VMM, you can't actually, we have no knowledge of extensions in a standard switch. So when we talk about virtual switch extensions, I've said some of these advantages already, why you would use a virtual switch extension. Microsoft hasn't done everything possible in the switch, so there are always partners that can do things in different ways from us. These are a few of the partners that we're working with that are most likely to come to market quickest. Cisco Nexus 1000V is forwarding extension. The Inmon S-Flow is a capture extension. NEC OpenFlow is forwarding, and 5.9 is filtering. These are just some of the examples of the extensions that we know are being worked on and we've partnered with. For those of you that don't know, forwarding extension is one that actually controls the flow of the packets through the switch. So these are actually extensions that know about the different types of networks you have. Capture extension really just looks at the packet. They're also called monitoring extensions. I think there is a subtle difference between capture and monitoring, but for the most part, they just look at the packets and report on what they see. And a filtering extension can be a firewall or any type of extension that needs to look at the packet and actually modify it. In VMM, we actually ship an extension as well. When you install VMM and add a host to VMM, we install actually a DHCP extension as well for network virtualization. I'll talk a little bit about that later, but that is a filtering extension, because what it does is it captures a DHCP request and then responds back using the IP address that we allocated from the virtualization tables. So that's another example of a filtering extension that we have in the box in VMM. So I talked about the different types of extensions, and basically the way they work is you install them on the host and enable them on the switch, and then for each port, you specify essentially a port profile ID on that port. The HyperV host and switch doesn't really know what that port profile is supposed to do, so the extension goes out and talks to its own database or its own console that has the information about this port profile ID. So whenever a packet goes through there, it knows what to do with it, and HyperV doesn't need to know what the actual functionality is beyond the basic three classes you see here. Now, in order for VMM to manage it, VMM has to be able to set these port profiles. We do this through our agent, through WMI directly from the VMM server. And we also need to be able to talk to these third-party network management databases so that we can import the port profiles and make them available to users to select and manage in VMM. We also need to be able to query what extensions actually are out there. So we also have ways of querying that there actually is an extension installed into VMM and that we can actually deploy it. So we worked with the Windows Server team to define very specific packaging requirements for these extensions so that we can make sure that we can actually install them, or actually any management tool can install them remotely. So we get port profiles from these databases. But as I mentioned briefly, in the case of forwarding extensions, these forwarding extensions know a lot about the network that's out there. They know what what logical networks exist. They know about IP pools. They even know about tenant networks. So they have a lot of information that in the first session I entered manually into the VMM console. But through this plugin interface, we've actually enabled it so that we can import these directly. So the network admin that's sitting at this network management console and is using the tools that they're familiar with doesn't have to email and tell the VMM admin what to do. The VMM admin just it just gets refreshed in automatically through the plugin interface. So you see I mentioned tenant networks down there in the bottom. And when I talked about isolation also in the first session, I also left one thing off. There's actually one more type of isolation we support. And that is isolation through an external switch extension. Because these extensions, when they control the forwarding, they can actually implement isolation. They can do it through whatever means is completely opaque to us. Oftentimes it will be just VLANs, but it can be whatever the vendor chooses to implement. So you can actually select, so on these logical networks that we import from the switch extension through the management console, when you select one of those for the VM network, then we'll figure out what kind of tenant networks actually we also imported from that management console. The tenant itself doesn't really know the difference. They don't know if they're using a VLAN VM network or one that we imported from a forwarding extension. So to the tenant, they're all, the idea is that they all look the same. So let's actually jump in, and I'm just going to start showing you some switch extensibility, how we manage it. First, I'm going to go to the logical switch that we actually deployed and created in the first session. That should be here, right here. This is the data center switch. You saw me create this. I haven't touched this environment since we, other than to show you the virtual port profile. I haven't touched this environment since we created it earlier. And it's installed on one host, for those of you that didn't see it. We have a virtual switch on here that uses that port profile. Virtual switch, here's the logical switch that we used on the host. Now, if you recall, when I created the logical switch, I did not actually select an extension. I said, just use all the native settings. But I did have an extension installed. I have the SFlow agent. So the SFlow is made by, this SFlow agent is an extension made by a company called Inmon. They use the standard SFlow protocol to do traffic analysis of the network. If I now actually want to use that on my host, so I've already done one step ahead of time, and that was to actually install the provider into VMM, so we know that the extension is available, and then it also installs an MSI package. I can actually show you on the VMM server where that MSI package goes. If you go to the program data, switch extension drivers folder, as you can see, there's actually an MSI in here. This is one that got installed along with that SFlow extension. And this is where we'll pull the extension from. We copy this MSI to the host when we actually want to use the extension and kick off the installation of it. So in that way, you don't have to actually go out to every host individually. We'll go out and put the extension there when it's needed for that host. Where's my scroll bar? It's hiding there. Okay, so what I'm going to do now is I'm actually going to enable it now on this. I'm going to hit OK. Since this is a capture extension, there are no really port profile settings. It just captures and then sends the traffic off to its monitoring tool, to its collector. So I'm just going to hit OK. And what that's going to do now is it's telling VMM that I want this extension to be available on every host that uses this logical switch. So that includes the one that we just deployed. So I can actually go, and we have a view that we can use to detect if these physical machines are compliant with what's in the logical switch, because we haven't actually gone out and installed it yet. We don't do that automatically because some of these extensions could impact the workload that's running on the host. And so we won't do it automatically. You have to actually remediate it through an action in VMM. So what I'm going to do now is I'm going to go to another view we have here called the host view. So this is the pivot up top in the ribbon. And in the host view, we have a view that actually shows you whether or not certain objects in here are compliant with what's in the logical switch. So if I find my host 02, oh, there it is, one with the blue. Oh, look at that, it's not compliant. What a surprise. If I go down, it says need to update their extensions, either update the switch or out of band or the HyperV host. Okay, so we're basically saying that what's installed on the host doesn't match what we have in the logical switch. So look at this button up here, it says remediate. I can click that, and when I do that, what we'll actually do, I can go out and what's actually going to happen is we're going to actually go out and change the properties of that logical switch. We're going to figure out what's the delta between what we expect and what's there, and we'll go out and we'll actually install the extension if it's missing and enable it on that switch, because that's what you want and that's what you said. It'll then become compliant eventually after that extension gets installed, and and then you should be consistent across your data center. Yeah, there are cases when we can't actually update the do remediation, and we'll warn you, or we'll give you we'll keep the warning here saying that we couldn't actually remediate. You have to actually go in and manually do some actions on that. So that just shows you how you can, by using the logical switch early, even if you don't want to use extensions yet, later on when you do choose to use them, it's simply a matter of updating one object and then remediating your host, and we'll go out and apply those configurations. So now I'm going to switch over to a different extension in a different plugin I have. And I'm actually going to show you the Cisco Nexus 1000 extension. So that's an extension that just went into beta a few weeks ago. This is a forwarding extension that you've probably heard a lot about. Oh, it's on my other window. And this is an example of a forwarding extension. And basically, what it does is it controls the flow of the packets through the switch, and then adds on its own capabilities beyond that. You can go read the Cisco documentation to find out exactly what all of its capabilities are. I don't even know everything that it can do, but it's like the kitchen sink of extensions, essentially. So what I'm going to do here is show you that I have a Nexus 1000 already installed in my environment. So I added it in the same way as I did the Inmon extension. I have a provider in my that I've installed. So if I go to my settings, here's the Cisco Nexus 1000. This provider is what lets us talk to the Nexus 1000 console. And then I've actually added an instance of the Nexus 1000 here as well. So if I go to my switch extension managers, you can see here I have the Nexus 1000V added to VMM. And as soon as you add this, you do it through the Add Resources wizard up here. You do Add Virtual Switch Extension Manager. Actually, I'm going to give it a connection string so that we can talk to it, credentials, and you scope it to what host groups you want it to be available on. And as soon as you do that, we'll start talking to that plugin and importing data. So you can see some of the network that we've actually imported already that we added it when we added it. This Internet ISP, for example. This one actually came from the Nexus 1000. I didn't enter this into VMM. It just showed up. The other thing we import are IP pool, we will import IP pools, but we also import port profiles as well. So if we go to the logical switch, here's my Cisco Nexus 1000 switch. Go to the properties where it's enabled. This initial logical switch actually gets created by the Cisco installer automatically. They have a really tight integration with VMM, and they actually call VMM PowerShell as part of their installation process to make it as seamless as possible. You can see we have this extension enabled here. And if you actually go to these uplink port profiles, for example, and edit it, well, here we took the Nexus 1000 uplink. So this came from the Nexus 1000. In the case of a forwarding extension, so before the uplink port profile, when I showed you in part 1, the uplink port profile I defined in VMM, because HyperV is what controlled the forwarding in the first example, because there was no forwarding extension. In the case of a forwarding extension, the uplink port profile comes from the extension. Since it's controlling the forwarding, it controls what that host is connected to. So this Nexus uplink came from the Nexus 1000. If I go to the virtual port and edit that, you can see now you actually have a choice of not just the native HyperV setting down here, which are still enabled and available. You also have the port settings from the Nexus 1000. So you actually have this, you can actually build this list or this set of port profiles that are applied to this single classification. So this is why we don't actually apply, part of the reason why we don't let you select a port profile directly on the VNIC, why you have this classification above, because the classification actually consists of multiple settings. If you have more extensions in here, you would have more settings available on the switch port, on every switch port. So you can combine them together and use the group of settings that apply the best to your port. And so you can build up this library of port profiles within the logical switch. So what I'm going to do now is I'm actually going to go to the Nexus 1000 console and create some new objects, and we'll see them appear in VMM. Okay. And let's see if it's still on my clipboard. Actually, I'll copy it again so I don't. It's always fun typing in front of a large group, so that's what the clipboard's for. So I'm going to paste this in. So what this is doing is, first thing it does is it, oh, whoops, what did we do? Oh, I made one change to it beforehand. I just have to fix that. Let's do this one again. That's what I get for making changes at the last minute. I tried to rename it. I was going to keep it called Tenant Networks. There it is. this again. Oops. Didn't need that one. One more. Now let's try it. Oh, I did something else wrong. Here, let me do one more thing to get us back to where we belong. I'll just revert back to my snapshot of the N1K. Services. And it's checkpoints. There we go. So what I'm going to do is I'm just going to restore it back to the state I was in before so that it's in a known state. I don't know if this is actually something that Cisco would recommend, but it works for demos. So as soon as that finishes, then we'll be back to the state for my clean start again. So while that's working, I'll show you what's actually in the script that I'm running. It's on this one. So these are Cisco commands. If you're familiar with Cisco, you know how to enable commands on a Cisco device, whether it's a physical switch or Nexus 1000V. You know, these should look familiar to you. But there are a few that I think are unique to the HyperV implementation. So here you create a logical network, and I say I want this to be called tenant networks, and then I add network segments within that. So within that tenant network's logical network, I'm going to say there's a rack 2 tenant segment, and I'm essentially defining my network sites in this case. And then I'm exposing that tenant as a tenant VLAN, as essentially a tenant network then that I can use for my tenants to provide that external isolation, in this case using VLANs. The last thing the script does is it does create a port profile that we can then use also to apply to the ports to define the capabilities of that port for the switch. So let's select these again. Let's try this one more time. So I'm going to go back down to my fabric, and I am going to refresh this in just to make sure we got our settings back to where they belong. So I'm going to hit the refresh. So what we're doing is we're actually going out now to the Nexus 1000 and re-updating all of the objects that we imported from it. So let's try this again. So let me go back down to my console. I'll need to reconnect because when I reverted the checkpoint, once we open that, when I reverted the checkpoint, I lost my connection. So let's log back in again. All right, so let's see. That's looking better. Okay, there we go. So we created the logical network, the network segment, and the port profile. So now, these are now in the Nexus 1000. So I'm just going to go back now and refresh one more time in VMM, and I'm going to go up to my logical networks. And if you watch carefully, you will see something change here in a second. So what we're doing now is we're going out talking to the Nexus 1000. There it is. So we just pulled in this logical network from the Nexus 1000. I created my console, so your network admin could have created it in the Nexus console, and VMM will pull it up, and now it's available to use in the virtualization environment. I also created a tenant network. So if I actually go back up to my VM networks view and create a VM network, just like I did in the first session, create VM network, and this time select that new logical network that we just imported. Let's call it tenant 1. And select the tenant networks. This was the new one. This is why I wanted to rename it, because these two were too close. So I edited the script. And here I can see, here's the tenant VLAN 400 that we just imported from the N1K. So now, essentially what I'm doing is, much like when I pulled the VLAN from a pool of VLANs, I'm now pulling this network that the network admin created from the pool of networks and realizing it in VMM. And so as long as this tenant wants to use the network, they can. When they delete their network, that network that we imported from Cisco will get put back into the pool. It'll be available for other uses. Now, if I go down to the port profiles, we can see that I actually did import the port profile as well on my logical switch. So if I go to the port profile and I just add a new one, actually I'll just edit this one. You can see that the tenant access one is the one that I created for my script. So this is now available, and as the Cisco admin adds more, then they just become available for the virtualization admin to use. So that's one of the nice things about the tight integration, is that we are able to pull that data in, use it all together. Okay. All right, so depending on what extensions you have, basically the flow is the same. You add the extension, we import data. You add the manager, we import data, and then you can use that extension on the logical switch. That's why we strongly recommend that you use logical switches, as early on as you can in the deployment of your data center, because it'll get you in so that you can easily then apply these extensions later on. So now let's shift gears and talk about network virtualization. I mean, this is kind of a new hot topic as far as SDN is concerned. It's been talked about for, I think the first build was a year and a half ago, where Windows Server started talking about network virtualization in HyperV. And really what network virtualization gives you is it gives you the isolation without reconfiguring your network. I think I've talked about all of these a few times now. So you understand the advantages of it, why you get this flexibility since you are independent from your network. What it does, is it lets you separate from your physical data center and carve out completely the pieces of your tenant data center. Or you give your tenants their own virtual version of that physical data center. Each one is independent, and they can each deploy their own applications in there as well. Before we had server virtualization and with VMs, we had virtual hard disks for the VHDs, but the networks really until now were just, your only virtual network was the virtual switch, and that was tied to a single machine. But now with network virtualization, you really have a truly software-defined environment for your tenants, where they can deploy their own applications. But a network is unique in this multi-tenant infrastructure, because the network, the people that use that network, that need to get access to that, aren't virtual, right? These people are real people that access real networks. Microsoft Research may be working on virtual people for the networks, but it's not there yet. So for now, these physical people have to get to the virtual network somehow. And so you need a piece called a network virtualization gateway. This is what takes the packets and translates them essentially into something that you route on the network where your users can get to. The reason for the gateway is because as long as the packets are in the virtualized environment and they're going from host to host, even if those hosts are in different subnets, HyperV, as the packet leaves the virtual switch, will encapsulate it when it puts it on the wire in a packet format called NVGRE. NVGRE is an extension of an existing format that we're working on the standards process to be able to standardize that extension of the existing format. So if you're familiar with GRE as a packet format, this is really just an extension, basically adding that, using that GRE key field as the virtual subnet ID, so that we can tell when these packets arrive at the destination which VM they're going to go to. So even though they contain the same address here, right? Each customer address space completely overlaps with the same VMs. On the outside, and even on the outside they're the same because they're going to the same host. Inside we know that they are unique tenants and they go to unique destinations. VMM manages the policy on the host to make sure that we give the host the information it needs so that it can map these provider addresses, so on the left side in the white square rectangles, to the customer address spaces on the right side. Now, you may be thinking, oh, well, this means that VMM, since it's updating these policies, is the single point of failure. But we really recommend that you deploy VMM. VMM supports HA deployment. So VMM can be in an HA mode where you have an active standby. And then really the only time that VMM will be down, the only time you'll have no policies getting updated is as VMM is failing over from one to another. And if VMM isn't in your environment, if VMM is down, your environment's not going to be dynamic, right? So you're not going to have changes happening that VMM would need to do updates for anyway during this failover. Because once VMM sets the policy on the host is independent as long as the environment doesn't change. It can do the necessary forwarding of the packets and encapsulating without VMM being involved. The only time when something could happen without VMM is if you did an out-of-band move, such as using HyperV Manager or Cluster Manager to do the move, or if a failover happened in that brief period while VMM was restarting. We also did a lot of work in SP1 to make sure that VMM did start up as quickly as possible. So you've probably seen improvements in this area in general of VMM having increased performance, and that's one area where it benefits. So the packet arrives on the destination, and that's where it goes. So if we look how the diagram that I've been using throughout these sessions changes when you have network virtualization, instead of connecting the gateway, your physical gateway, to your tenants with a VLAN, you have what we call the provider network that sits in between. The provider network is what essentially is your physical network. It's a traditional network. You can still use VLANs and route between the VLANs. You have to have connectivity between all the hosts that are on that provider network in order for the packets to get sent. But that provider network then virtualizes the tenant networks that are connected to it. But in order to get out of that provider network, as I said before, you have to have the network virtualization gateway. That's what enables you to get outside of your provider network. So now let's go into our fabric and see how to set up the provider network. I can take questions at the end so that we get through everything. I'll leave plenty of time for questions, and I don't have to run to another session after this, fortunately. Let's see here. Okay, so let's go back to our original fabric that we set up in the other session. Server, okay. So I'm going to go to my logical network where I set up my, go to my resources view. And I'm going to create a new logical network for my provider address space. So essentially you saw a new pipe on the other diagram that essentially, in this case, means a new logical network. So I'm going to call this my tenant networks. I don't think I already have one with that name on here. Yeah. So I'm going to call this my tenant. I'll call it my tenant fabric. Oops, not my tenant. And I'm going to check this box that says, allow new VM networks to create on this logical network to use network virtualization. There are some networks that you just don't want network virtualization to be used on for whatever reason. And so this basically tells VMM, don't let the user create a VM network on here. It doesn't affect VMs that were already created, so you can actually turn this on and off at any time. And so while it's on, if you create networks, VM networks on this using network virtualization, they'll stay there, the VMs will continue to use them. You have to manually clean them up at some point. But this is what you'll do to turn on when you're ready to use network virtualization. You can turn it on at any time. And one thing that network virtualization requires, because it needs to send packets on the wire using that provider address that it knows about, that it uses for the encapsulation, it needs a static address pool, and it needs a subnet that it can use for those addresses. So I'm going to create a site for my Rack 1 tenant fabric. Rack 1. It's in my new data center still. And I'm just going to use VLAN 0 for this one and give it 10.1.4.0. And so if I had another rack that's on a different VLAN, for example, and I have my switches configured to route between them, I would add that as a separate site so that each one gets its own definition, same as you did basically for a standard logical network. So there's nothing really unique here other than the fact that I clicked that allow box early on. So I'm going to finish this up. I'm going to create that logical network, and then I'm going to create an IP pool on it so we can get addresses for the provider. The tenants won't see this pool. They won't have access to it. It's only for VMM to use to be able to allocate addresses from it. So I'm going to use my existing site and create a pool. Okay, so I create a pool for VMM to allocate these provider addresses. VMM handles all of the allocation and deallocation automatically. Whenever a VM using a particular VM network lands on a host, we'll allocate a provider address just for that network so that it can be used to route between the hosts. We do that. We allocate multiple provider addresses so that load balancing, if you're using teaming in the switch on those physical adapters, load balancing will spread the packets more evenly than if we use just a single provider address. But we could, the technology allows them to be shared. There's one other address pool I'm going to create, and that is you may have seen the option for it, a multicast pool, because you can do multicast within a virtual network as well, using network virtualization, multicast. So my tenant fabric. And you do that by checking this box that says create a multicast IP address pool. Oh, I have to give it a name for the site, because we'll create a site for it automatically. Narrow down the range if you want. So what VMM will do, again, if it detects a multicast is being used, it will automatically allocate a multicast address, so those packets will be sent out on the wire using multicast. Okay, so I've created the basic fabric of my logical network. I still have to make it available on the host. And here's again where the advantage of the logical switch comes in, is that I'm going to do it only in one place, and that's on the port profile that I use for my host. If I had a cluster of these hosts, I wouldn't have to go and do it on each cluster. I'll simply go here and say that I want my tenant fabric enabled and the multicast one enabled. And then this is also very important. So in order for the packets to get encapsulated with the NVGRE as they go out on the wire, there's actually a filter driver that runs in HyperV. That filter driver runs in between the virtual switch and the physical adapter, and that's the component that actually does the encapsulation and decapsulation. As the packets go out of the switch, the filter gets the packet and sends it on its way. When it comes back in, it removes the encapsulation, tags that packet with the virtual subnet ID for that packet, and then sends it on to the VM. So without this being enabled, then there would be no encapsulation. The packets would just get dropped at the switch. Pardon me? Well, since all the packets, so the management network and the network virtualization packets can coexist on the same virtual switch. As the packets are in the virtual switch, they are tagged in the out-of-band data with the virtual subnet ID of the packet. So they'll be kept separate in the switch and isolated within the switch. As those packets go through the network virtualization filter, the ones that don't have a virtual subnet ID tagged on them will just get passed straight through. Now, those can use VLAN tagging, they can use whatever the switch supports, but those can just pass right through the filter. It's only the ones that are tagged with a virtual subnet will get actually acted on with the filter. Will it work in multi-what hypervisor? Multiple types of hypervisors? No, this is only available on HyperV network virtualization, for HyperV. Okay, so I've enabled that on the rack, so now it's available for that host, for my HO2 host. So then the last step, actually the next step that I'm going to do is, as I mentioned, you need a gateway. So I want to actually add the gateway yet. I'm going to go ahead and go back to my slides for just another minute before I do the gateway. Oops, wrong deck. So that's basically all there is to the fabric, to the basis of fabric. I'll still add the gateway. I'll do that in a minute, but I want to talk a little bit more about the gateway first, just so you understand really what it does. I mentioned before, it's what lets your users on your physical networks and any other infrastructure that needs to talk into these virtual networks get through. And there are two basic modes, or two scenarios that we're targeting for this first release of network virtualization with VMM. What we call the hybrid cloud and the private cloud. Private cloud is very simple. You have a local network that you basically want to route the packets onto from the virtual network that you have in your data center. So this would be a typical corporate environment. You have a corporate network with two sites. Those are the blue ones on the right. They have a regular physical corporate network, which is the green line on the right. And that's connected to the data center through the network virtualization gateway. In this case, it's owned by the corporate, the enterprise that's operating this data center and has the network on the right. So as a packet comes from the corporate side and goes through, normal routing is used to get to the gateway. When that packet gets into the gateway is going to look and see, okay, where it has the routing rules to figure out where is this packet going to go. And as it does that, it encapsulates the packet using NVGRE and sends it on the wire. Once it gets on the wire, it goes to the host. The host has its own router built in that figures out, okay, is this where the packet needs to go? And if it is, then it forwards it on to the VM. So in this case, that gateway really is just acting as a router, but doing some decapsulation and encapsulation on the left side as the packets go in and out. The hybrid cloud is very similar, except the key difference is that you have two endpoints of a VPN that VMM configures one of. VMM will configure the NVGRE VPN endpoint so that a tenant of a hoster could create their own network in the hoster environment, specify their VPN settings so that the hoster can talk then to the customer's on-premise VPN endpoint, and VMM will go out and tell the gateway, okay, here's a new virtual network, and here's the VPN endpoint to connect that virtual network to. This allows a hoster to have multiple tenants in their environment, each one with their own address space, because the packets of that virtual network are never routed unencapsulated on the hoster's physical network. It's always going through that VPN gateway. It's encapsulated using a standard VPN packet, and then gets re-encapsulated using the NVGRE. Nowhere other than on the corp network is that packet sent without being encapsulated. So it doesn't matter what its address space is internally until it gets to the corporate network on the right. In the previous one, in the private cloud, I go back far enough. Here you have to be careful because the subnets within these VM networks can't overlap outside of the, even among other VM networks in the environment, because that router, the gateway, the Contoso gateway there, has to be able to, when a packet comes in, know which subnet to put it onto. And if there were multiple subnets, then it wouldn't know where to put it. If NAT were available in the gateway, which is not a scenario we support yet, then you could potentially do it, but not today. Oh, I was saying that technically it's possible for the gateway to do some NAT, but VMM has no awareness of it, right? So VMM can't configure it. It won't know that there's any NAT going on. So it's not one of the scenarios we targeted for this release. Okay, so through my animations. So what can you use network virtualization for with and without a gateway, right? Because none of you, I'm guessing, have a gateway, since they're now just starting to ship, with some announcements at MMS. With a gateway, you, of course, get these two scenarios where you can actually route your packets to and from the network. Without a gateway, you can actually still do some useful things with network virtualization. Any VM that has two NICs can have one NIC that's connected to a normal network, whether it's behind a load balancer or behind a PVLAN or even a regular routed network, and another NIC that's on a backend network that uses network virtualization. That backend network can talk to the other parts of whatever service it is that VM is representing, so you can get some isolation in that way. The other thing that's really useful for is dev environments and test environments. We're seeing some customers today already using it in this form. So they'll create a test environment that replicates their AD infrastructure and all of their infrastructure in a virtual network. And because there is no gateway, that's actually an advantage in that case, because now you know that you're isolated and you won't impact any of your production resources that are actually out on the same physical network. So those are your primary uses for what you can do without a gateway. So yeah, just to diagram it, if you don't have the gateway, then it goes that way. All right, so let's go back in. Let me talk a little bit more about the gateway, and then I'll actually create a VM network. And I'll show you a gateway in action. Okay, switch over. Okay. So the way you add a gateway to VMM is first, again, because it's a third-party device, we need to be able to talk to it. So you have to have a provider in. We have a sample provider here that we wrote ourselves for our own use. We're working on making that available to the public, but it's not available yet. When it is, you'll be able to use it for test deployments. It's not a production-ready gateway plugin, but you would be able to do proof of concepts with it. So once I have that plugin, I can then, and what that plugin does, it basically uses a Windows server to act as the gateway, because Windows Server can do all the encapsulation, decapsulation. And if you use the routing or remote access role within Windows Server, you can actually do the routing too then. So the initial gateways that are available publicly, such as the Iron Networks gateway that they have out on the show floor this week, that is a Windows-based gateway. Those can be brought to market really quickly because they're using Windows to do the encapsulation. And then all they have to do is add the routing in and configure it. Okay, so next step is to actually add the gateway device. So here's where the gateway devices go. So I'm going to add the gateway. So I go to Add Resources and Add Gateway. So this is going to be my gateway. You have to give it a set of credentials so you can talk to it. Gateway. You have to select which plugin you want to use in the event you have multiple plugins available for multiple gateways. You have to say which address it's going to use on the network to send the packets. So this is in the provider, it has to be in the provider address space. So in this case, I'm using 10.1.4.2. This is an address that you would configure on the gateway itself when you're setting it up as part of the gateway's installation process. It's on the tenant fabric logical network because that's the only one I have that has network virtualization enabled. Give it a connection string. This is what you'll use to actually talk to it. This is essentially the computer name if it is a Windows-based gateway. And then we have a way to test it. So I'm going to test. So pass. So we test the connection. We just verify that the functions are implemented in the plugin, but this should now work as a gateway. So I'm going to hit finish. Okay, so now I have this gateway available. So now I can actually start creating VM networks that use the gateway and use network virtualization in my environment. My fabric is done at this point. So now it's just a matter of any time a new tenant comes up, there's no fabric reconfiguration required. So here I go up to my same VM networks area where I created these networks earlier. I'm going to create a new VM network again. This is going to be I'll call this my blue tenant. I'm going to select since I have multiple logical networks that can support VM networks, I'm going to select my tenant fabric as the one that uses network virtualization. You see my options change now. I actually have the ability, an option now for VM subnets. So here I say I want to use network virtualization. I'm going to get an option of IPv4 or IPv6. And then here I can add my subnet. So one of the unique things about HyperV network virtualization is that built into every Windows host that's involved in the virtualization environment is a network virtualization router. So HyperV is able, if there are multiple subnets available, is able to route between those subnets as part of what's called a routing domain. So you can actually add multiple subnets. You can start with a single subnet in your virtualization environment, add additional ones later, and HyperV will actually handle the routing between those subnets automatically without actually going through the gateway and requiring the gateway to do any decapsulation. So I'm going to call this so you can have a finance subnet, and I can give this to be anything I want because it's completely isolated. If I am using a VPN to extend back, then I do need to use a subnet that is able to be routed on my corporate address space through the VPN. I can add another subnet too if I wanted to. I can go to 10.0.1.0.24. And my subnet is, I got that backwards. This would be my marketing subnet. And then I get a number of options for the gateway. So as a full administrator, I can actually connect. I can either connect to a remote network or a local network. A tenant administrator is only able to connect to a remote network. And I'll actually show you a tenant in a minute, because one thing we haven't done yet is actually enable tenants to be able to use this and do tenant self-service. I'm just going to select to connect it to a local network. Gateway will do the routing. We'll pass the information to the gateway on how to use this network. But that's really all there is to creating this newly virtualized network. So now one thing I need to do now, so I've been doing everything as a full admin. If I actually want tenant administrators to be able to do their own self-service network creation and deletion, I have to actually make that available to them, and you have to do that through a cloud. So what I'm going to do now is I'm actually going to go to my gold cloud and open the properties of that. And you have to make the logical network, or the fabric network that you created, available to the tenants to use. You have to do that because otherwise we wouldn't know which network to realize their virtual networks on. You generally only need to do one of these, and that's that. The other thing you can make available to the cloud that I want to show you are the port classifications. This is how you can actually have different classes of service within your environment for each cloud. So for example, if I have a gold cloud, I can enable the high bandwidth classification. My bronze cloud, I can use low bandwidth. So now anybody that's deploying to the bronze cloud, their traffic will be prioritized lower than the gold cloud, which you're probably paying more for. So this is another use of the classification concept that separates from what the actual port profiles are underneath. Okay, so I made the logical network available on the cloud. Now I have to actually create a tenant administrator to be able to use it. The tenant administrator is a new role in SP1 that basically is like a super tenant you could think of. A tenant administrator is able to manage the resources for a group of self-service users within the environment. There are super self-service users, I guess is what I meant to say. So they have some extra abilities that a regular self-service user doesn't, such as the ability to create VM networks of their own. So I'm going to create a VM network, or a tenant admin. I'm going to call it MMS user. I'm going to say that it is a tenant administrator. I'm going to make myself a member. So I am, VM admin. I'm going to scope myself to the gold cloud. Just use all the standard quotas. So on this panel, we have the ability to automatically assign access to certain, if you have shared VM networks, whether it's network virtualization or not, you can assign access to these shared networks here. I'm not going to do that now. And then here we have a new action that's new in SP1. It's author VM networks. So I'm going to check that off. And by checking that, we get a new panel where you can control the quota for how many networks this tenant is allowed to create. Run as accounts is just was from another action. But now the quotas, I have the ability to limit the individual users or limit for the entire user role. So this way I don't have my users going and creating a huge number of networks and sucking up the entire capacity of my gateway, for example. Because gateways will be limited in how many tenants they can support or how many virtual networks they can support. So I'm going to leave myself unlimited and finish this. Just create an MMS user. So now I'm actually going to sign in as that user and show you the experience from the tenant perspective. I'm going to go to open a new connection. Oops. Oh yeah, that's fine. So I'm going to log in as myself again, but I'll be prompted for the user role to log in as. Use the MMS user as the one I just created. Wait for the console to start up. So now you see the tenant view, and the tenant administrator view in particular is a little bit different than what the admin sees. You'll notice there's no fabric, so I have no idea what the fabric consists of. I still have the VM networks node though, and most of the VMs the services view. I still have create VM network action because as the admin I gave myself that. And so I can create a VM network. I'm going to give myself name it my network. I only have the one network that was available on the cloud here. And I can define my own VM subnets. So here I can also do 10.0.0.0, since this will be completely isolated and not actually sent on the wire of the hosted space in this unencapsulated. Don't have to worry about overlapping space here. And then here I basically, as a tenant, I only have the ability to do no connectivity or a remote network. If I do remote network, then I get VPN options for defining the VPN connection. This would be the IP address of my on-premise endpoint. And then I have a few options for how I want to authenticate with that environment. If you're using pre-shared keys, you would select this option up here. I'm actually going to switch over to my other server where I actually have a VPN endpoint set up, and I can show you both ends of this connection. So let's open up this VMM server here. So here I have a gateway. This is the sample gateway. I have, my connection is still up and running. Okay. So I have the gateway added. I have I have Wingtip Toys as my fictional tenant. This represents their on-premise network. If I go up to the VM service view, within their on-premise network, I have all my infrastructure, AD, DNS, DHCP. I have an on-premise VPN endpoint that I can actually open up. This is running routing and remote access. Oh, connect to that one. And you can see I actually have a connection here. So when you go and create the VM networks on the hoster side first and say I want to connect back to my on-premise endpoint, I'm giving the IP address of this VPN endpoint. But now in this VPN endpoint, I still have to create a configuration so that I know that this other endpoint that's calling in can route onto my network. And so in routing remote access, I do that through the network interfaces, and I simply create a new network interface here. I've already done this one. So we open up the properties. And what I do is I say which address is allowed to talk to me, and also if I need to establish a connection from my end, I need to know the hoster's VPN endpoint so that I can connect back into it. So the hoster needs to make that available to the tenant as well. So here's the hoster's endpoint, and then you have the other options. IPv2 is how RAS communicates with itself. And you have to enter in the pre-shared key if you're using pre-shared keys for the communication. This is what you would have specified in the VPN options when you created your VM network in the hoster. But with this created now, I can actually go to now a VM that's in the hosted environment, which is this up here in my gold hosts, my wingtip client. And if you look at it, it's connected to a VM network up here. So I should have a wingtip hosted network here. This wingtip hosted network, it has a couple different subnets. It has the gateway enabled, saying to go to a remote network, using a VPN connection directly across, authenticating using a pre-shared key. And then I just use all the default settings for connecting to routing remote access. So I have that up and running. So if I go to that VM, which is here, and I will make this font bigger so that you can see it. Even I have a hard time reading that. There we go, that's big. Okay, so I can see I have an IP address on one of the subnets that I created. This is actually sorted up through DHCP using the extension that we deploy. So if a VM does require DHCP, we can allocate that address without requiring a DHCP server to be in the virtual network. If I ping my wingtip web 1, if I got the name right. Oh, whoops, I got the name wrong. What's it called? Web 1. There we go. So I'm now pinging outside, pinging outside of my network. So this is actually going through the gateway. You can see it's a different address space. It's routing directly through the VPN tunnel onto the wingtip corporate address space. I can actually start up a file share from here, open up a, I can see it, my font too big. Now I can connect to a web server that's running on that client machine. Let's see it update at the current time. Oops, there we go. I can do start, wingtip. I can see there's a share out there. I can use it just like any other network that's out there. So this client machine that I'm using is on the virtual network, but I'm talking to a machine on a physical network through a VPN tunnel on premise. And here I can basically take any random file and copy it to my desktop. So it does the copy back and forth seamlessly. The tenants don't really even know that there's network virtualization under the hood. Okay. Left. Is there anything? That's it. I think I covered everything that I possibly could about VMM networking. If I didn't, please come up here and ask me, and I'll make sure I add it next time and answer your question at the same time. So thank you for coming and being with me for 3 hours, and I'm going to give my mouth a break now. So thank you all. Enjoy the rest of your show.